Find the domain of the rational function. f of x equals 4 divided by the quantity x minus 3. The domain of this function is all points where the denominator is not equal to 0, because you cannot divide by 0. So x minus 3 cannot equal 0. Solve for x. X cannot equal 3. The domain of the function is all points besides 3. Meaning the domain is negative infinity to 3 and 3 to infinity. Find the domain of the rational function. f of z equals z plus 2 divided by the quantity z times the quantity z minus 4. The domain of this function is all points where the denominator is not equal to 0. So z times the quantity z minus 4 is not equal to 0. Either factor in this expression can be equal to 0. Z cannot equal 0 and z minus 4 cannot equal 0. Solve the second equation for z. Z cannot equal 4. The domain of this function is all points where z is not equal to 0 and z is not equal to 4. The domain is negative infinity to 0, 0 to 4, and 4 to infinity. Find the domain of the rational function. f of t equals 5t divided by the quantity t squared minus 16. The domain of this function is all values of t where the denominator is not equal to 0. Set the denominator equal to 0 and solve for t. T squared minus 16 equals 0. This expression can be factored into t plus 4 and t minus 4. The quantity t plus 4 times the quantity t minus 4 equals 0. This expression is equal to 0 when either of the factors are equal to 0. So set both factors equal to 0 and solve for t in each case. T plus 4 equals 0. Subtract 4 from each side. T equals negative 4. T minus 4 equals 0. Add 4 to each side. T equals 4. So the domain of this function is all values of t besides negative 4 and 4. The domain is negative infinity to negative 4, negative 4 to 4, and 4 to infinity. Describe the domain of a rectangle of length x inches and an area of 500 square inches. The perimeter of the rectangle is given by p equals 2 times the quantity x plus 500 divided by x. Because x represents a length, x has to be positive. X has to be greater than or equal to 0. In the term 500 divided by x, the denominator cannot be equal to 0. So x cannot be equal to 0. X has to be greater than 0. The inventory cost I, when x units of a product are ordered from a supplier, is given by I equals 2500th x plus 2000, all divided by x. Describe the domain. The denominator cannot be equal to 0, so x cannot be equal to 0. Because x represents the number of units, it cannot be negative. X has to be greater than 0. X also has to be an integer because you cannot order a fraction of the unit. So the domain is all integers greater than 0. Simplify the rational expression. 3x squared minus 9x all divided by 12x squared. Start by factoring 3x out of the numerator. 3x times the quantity x minus 3 all divided by 12x squared. The denominator can be rewritten as 3x times 4x. 3x times the quantity x minus 3, all divided by the quantity 3x times 4x. There is a 3x in the numerator and denominator, so they cancel out. This leaves you with x minus 3 divided by 4x. Simplify the rational expression. X squared times the quantity x minus 8 divided by x times the quantity x minus 8. The x squared can be rewritten as x times x. X times the quantity x minus 8 divided by x times the quantity x minus 8. An x in the numerator and the x in the denominator cancel out. And the x minus 8 in the numerator and the x minus 8 in the denominator cancel out. This leaves you with x. This function has the same domain as the original function. So find the domain of the original function. The denominator cannot be equal to 0. So set the denominator equal to 0 and solve for x. X times x minus 8 equals 0. When either factor is equal to 0, the entire expression is equal to 0. So set each factor equal to 0 and solve for x. X equals 0. And x minus 8 equals 0. Add 8 to each side. X equals 8. So the expression can be simplified to x, where x is not equal to 0 and x is not equal to 8. Simplify the rational expression. U squared minus 12u plus 36 divided by u minus 6. The numerator factors into u minus 6 times u minus 6. So this can be written as u minus 6 times u minus 6, all divided by u minus 6. A u minus 6 cancels out from the numerator and denominator. This leaves you with u minus 6. This expression has to have the same domain as the original expression, so find the domain of the original expression. In the original expression, the denominator is u minus 6. The denominator cannot be equal to 0, so set u minus 6 equal to 0 and solve for u. U minus 6 equals 0. Add 6 to each side. U equals 6. So the domain of this function is all values where u is not equal to 6. So the expression is u minus 6 where u is not equal to 6. Simplify the rational expression. Y cubed minus 4y divided by y squared plus 4y minus 12. Factor a y out of the numerator and factor the denominator into y minus 2 and y plus 6. Y times the quantity y squared minus 4 divided by the quantity y minus 2 times the quantity y plus 6. The y squared minus 4 in the numerator can be factored into the quantity y plus 2 times the quantity y minus 2. Y times the quantity y minus 2 times the quantity y plus 2 divided by the quantity y minus 2 times the quantity y plus 6. The y minus 2 in the numerator and denominator cancel out. You are left with y times the quantity y plus 2 divided by the quantity y plus 6. This expression has to have the same domain as the original expression. In the original expression, there is a y minus 2 in the denominator, so y minus 2 cannot be equal to 0. Add 2 to each side. This means that y cannot be equal to 2. So the simplified expression is y times the quantity y plus 2 divided by the quantity y plus 6, where y is not equal to 2. Simplify the rational expression. 3x squared minus 7x minus 20 divided by 12 plus x minus x squared. Start by factoring a negative 1 out of the denominator. You get 3x squared minus 7x minus 20 divided by negative 1 times the quantity x squared minus x minus 12. 3x squared minus 7x minus 20 can be factored into 3x plus 5 and x minus 4. X squared minus x minus 12 can be factored into x plus 3 and x minus 4. There is an x minus 4 in both the numerator and denominator, so they cancel out. You are left with negative 3x minus 5 divided by x plus 3. This expression has to have the same domain as the original expression. In the original expression, there was an x minus 4 in the denominator, so x minus 4 cannot be equal to 0. Set x minus 4 equal to 0 and solve for x. Add 4 to each side. X equals 4. So the simplified expression is negative 3x minus 5 divided by x plus 3, where x is not equal to 4. Simplify the rational expression. 2x squared plus 19x plus 24 divided by 2x squared minus 3x minus 9. Factor both the numerator and the denominator. The numerator factors into 2x plus 3 and x plus 8, and the denominator factors into 2x plus 3 and x minus 3. The 2x plus 3 in the numerator and in the denominator cancel out. You are left with x plus 8 divided by x minus 3. This expression has to have the same domain as the original expression. You took a 2x plus 3 out of the denominator. When 2x plus 3 is equal to 0, the denominator is equal to 0 and the expression is undefined. Solve 2x plus 3 for x. Subtract 3 from each side. 2x equals negative 3. Divide each side by 2. X equals negative 3 halves. So this expression is undefined at x equals negative 3 halves. Simplify the rational expression 3xy squared divided by the quantity xy squared plus x. In the denominator, the greatest common factor is x, so factor out an x. 3xy squared divided by x times the quantity y squared plus 1. The x in the numerator and the x in the denominator cancel out. You are left with 3y squared divided by the quantity y squared plus 1. This expression has to have the same domain as the original expression. You took an x out of the denominator in the original expression. If x was equal to 0, then the denominator would be equal to 0 and the expression would be undefined. So x cannot be equal to 0. Simplify the rational expression. Y squared minus 64x squared divided by 5 times the quantity 3y plus 24x. The numerator can be factored into y plus 8x and y minus 8x, and a 3 can be factored out of the denominator. Y plus 8x times y minus 8x divided by 15 times y plus 8x. The y plus 8x in the numerator and in the denominator cancel out. This leaves you with y minus 8x divided by 15. The domain of this expression has to be the same as the domain of the original expression. The denominator of the original expression cannot be equal to 0, so set it equal to 0 and solve for x and y. 15 times the quantity y plus 8x equals 0. Divide each side by 15. Y plus 8x equals 0. Subtract 8x from each side. Y equals negative 8x. So the domain of the original function is all points where y is not equal to 8x. The simplified expression is y minus 8x divided by 15, where y is not equal to negative 8x. Simplify the rational expression. 5xy plus 3x squared y squared divided by xy cubed. An x and a y can be factored out of the numerator. xy times the quantity 5 plus 3xy, all divided by xy cubed. There is an xy in the numerator and in the denominator, so they cancel out. You are left with 5 plus 3xy divided by y squared. This expression has to have the same domain as the original expression, so find the domain of the original expression. The denominator cannot be equal to 0. Set the denominator equal to 0 and solve for x and y. xy cubed equals 0. This expression is equal to 0 when either factor is equal to 0. So set each factor equal to 0. X equals 0 or y cubed equals 0. Take the cubed root of both sides. Y equals 0. So the simplified expression is 5 plus 3xy divided by y squared, where x is not equal to 0 and y is not equal to 0. Simplify the rational expression. U squared minus 4v squared divided by the quantity u squared plus uv minus 2v squared. The numerator factors into u plus 2v and u minus 2v, and the denominator factors into u plus 2v and u minus v. The u plus 2v in the numerator and denominator cancel out. You are left with u minus 2v divided by u minus v. This expression has to have the same domain as the original expression. U plus 2v cannot be equal to 0, because if it were, the denominator would be equal to 0. Set u plus 2v equal to 0 and solve for u and v. U plus 2v equals 0. Subtract 2v from each side. U equals negative 2v. So this expression is undefined for u equals negative 2v. The final expression is u minus 2v divided by u minus v, where u is not equal to negative 2v. Simplify the rational expression. 3m squared minus 12n squared divided by m squared plus 4mn plus 4n squared. Factor the numerator and denominator. The numerator factors into 3 times the quantity m squared minus 4n squared, and the denominator factors into m plus 2n times m plus 2n. M squared minus 4n squared can be simplified further. 3 times the quantity m plus 2n times the quantity m minus 2n divided by the quantity m plus 2n times the quantity m plus 2n. And m plus 2n in the numerator and denominator cancel out. You are left with 3 times the quantity m minus 2n divided by the quantity m plus 2n. This expression has to have the same domain as the original expression. The only thing you took out of the denominator was m plus 2n. Because there is still an m plus 2n in the denominator, this expression has the same domain as the original expression. Find the ratio of the area of the shaded portion to the total area of the figure. The area of a rectangle is equal to the width times the height. So the area of the shaded portion is equal to the quantity x plus 1 times x. And the total area is equal to the quantity x plus 1 times the quantity x plus 3. The ratio of the area of the shaded portion to the total area of the figure is the area of the shaded portion divided by the total area, which equals the quantity x plus 1 times x divided by the quantity x plus 1 times the quantity x plus 3. The x plus 1 in the numerator and denominator cancel out. You are left with x divided by x plus 3. This expression has to have the same domain as the original expression. Now find the domain of this expression. There was originally an x plus 1 in the denominator, so x plus 1 cannot be equal to 0. This means x cannot be equal to negative 1. Also, x represents a length. Because it represents a length, it has to be greater than 0. So x has to be greater than 0. There is no need to write that x cannot be equal to negative 1, because if x is greater than 0, then it is not equal to negative 1. So the ratio of the area of the shaded portion to the total area of the figure is x divided by x plus 3, where x is greater than 0. Find the ratio of the area of the shaded portion to the total area of the figure. The area of the triangle is 1/2 of the base times the height. So the area of the shaded region is 1/2 times x times the quantity x plus 1. And the total area of the triangle is 1/2 times 2x times the quantity 2x plus 2. The ratio of the area of the shaded portion to the total area is the area of the shaded region divided by the total area, which is equal to 1/2 x times the quantity x plus 1 divided by 1/2 times 2x times the quantity 2x plus 2. Factor a 2 out of the 2x plus 2 in the denominator. You are left with 1/2 times x times the quantity x plus 1 divided by 1/2 times 2 times x times the quantity x plus 1. The 1/2 and x and the quantity x plus 1 cancel out from both the numerator and denominator. You are left with 1/4. Find the domain of this expression. There was an x times the quantity x plus 1 in the denominator, so x times the quantity x plus 1 cannot be equal to 0. The left side of this equation is equal to 0 when either factor is equal to 0, so set each factor equal to 0 and solve for x. X equals 0 or x plus 1 equals 0. For x plus 1 equals 0, subtract 1 from each side. X equals negative 1. So x cannot be equal to 0, and x cannot be equal to negative 1. X represents a length, so it has to be greater than 0. So the domain is x has to be greater than 0. The ratio of the area of the shaded region to the total area of the figure is 1/4, where x is greater than 0. Determine the missing factor. 7x squared divided by 3y times the missing factor equals 7 divided by 3y, where x is not equal to 0. Solve this by cross multiplication. The numerator of the left side of the equation times the denominator of the right side of the equation equals the denominator of the left side of the equation times the numerator of the right side of the equation. 7x squared times 3y equals 7 times 3y times the missing factor. The 7 times 3y on each side of the equation cancels out. This leaves x squared as a missing factor. Determine the missing factor. 3x times the quantity x plus 2 squared divided by x minus 4 times the missing factor equals 3x divided by x minus 4, where x does not equal to negative 2. With this missing factor, terms in the numerator and denominator of the left side of the equation have to cancel out so it looks just like the right side of the equation. In the numerator of the left side of the equation, there is 3x times the quantity x plus 2 squared. In the numerator of the right side of the equation, there is 3x. The left side of the equation has an x plus 2 squared, where the right side of the equation does not. This x plus 2 squared has to cancel out. The denominator of the left side of the equation is x minus 4 times the missing factor, and the denominator of the second side of the equation is x minus 4. The only difference is this missing factor, therefore the missing factor has to cancel out entirely. Therefore, the missing factor has to be x plus 2 squared, because the x plus 2 squared in the numerator and in the denominator would cancel out. Multiply and simplify. 4x times 7 divided by 12x. Rewrite this as one fraction. 7 times 4x divided by 12x. Factor of 4x out of the denominator. 7 times 4x divided by 3 times 4x. The 4x in the numerator and denominator cancel out. You are left with 7/3. The domain of this expression has to have the same domain as the original expression. You took 4x out of the denominator. If 4x is equal to 0, then the entire expression is undefined. So set 4x equal to 0 and solve for x. 4x equals 0. Divide each side by 4. X equals 0. So x cannot be equal to 0. Multiply and simplify. 8s cubed divided by 9s times 6s squared divided by 32s. Multiply the numerators and denominators. 8 times 6 times s to the 5th divided by 9 times 32 times s squared. Break the 6 into 3 times 2, the s to the 5th into s squared times s cubed, the 9 into 3 times 3, and the 32 into 8 times 2 times 2. 8 times 2 times 3 times s squared times s to the 3rd divided by 3 times 3 times 8 times 2 times 2 times s squared. The 8's cancel out. A 2 from the numerator and denominator cancel out. A 3 from the numerator and denominator cancel out. And an s squared from the numerator and denominator cancel out. You're left with s cubed divided by 3 times 2, which equals s cubed divided by 6. The domain of this expression has to be the same as the domain of the original expression. You took an s squared out of the denominator. If this s squared was equal to 0, then the entire denominator would be equal to 0 and the expression would be undefined. So s squared cannot be equal to 0. Solve this equation for s. Take the square root of both sides. So s cannot be equal to 0. Multiply and simplify. 16u to the 4th power times 12 divided by 8u squared. Write this as one fraction by multiplying the 16u to the 4th power and the 12. 16u to the 4th power times 12 divided by 8u squared. Write the 16 as 8 times 2 and the u to the 4th power as u squared times u squared. 8 times 2 times u squared times 12 divided by 8 times u squared. The 8's cancel out. One of the u squareds in the numerator and the u squared in the denominator cancel out. You're left with 2 times u squared times 12, which is equal to 24u squared. This expression has to have the same domain as the original expression. You took a u squared out of the denominator. If that u squared is equal to 0, then the denominator is equal to 0 and the entire expression is undefined. So u squared cannot be equal to 0. Solve this equation for u. Take the square root of both sides. U cannot be equal to 0. So the simplified expression is 24u squared, where u is not equal to 0. Multiply and simplify. 8 divided by the quantity 3 plus 4x times the quantity 9 plus 12x. Multiply the numerators and denominators. For 9 plus 12x, the 9 plus 12x is the numerator, and the denominator is 1. 8 times the quantity 9 plus 12x divided by the quantity 3 plus 4x. Factor a 3 out of the numerator. 3 times 8 times the quantity 3 plus 4x divided by the quantity 3 plus 4x. The 3 plus 4x in the numerator and denominator cancel out. You're left with 3 times 8, which equals 24. This expression has to have the same domain as the original expression. You took a 3 plus 4x out of the denominator. When 3 plus 4x is equal to 0, the denominator is equal to 0, and the entire expression is undefined. So 3 plus 4x cannot be equal to 0. Solve this equation for x. Subtract 3 from each side. 4x cannot be equal to negative 3. Divide each side by 4. So x cannot be equal to negative 3/4. So the simplified expression is 24, where x is not equal to negative 3/4. Multiply and simplify. 8u squared v divided by the quantity 3u plus v times u plus v divided by 12u. Multiply the numerators and denominators. 8u squared v times the quantity u plus v divided by the quantity 3u plus v times 12u. Write the 8 as 4 times 2, the u squared as u times u, and the 12 as 3 times 4. 4 times 2 times u times v times the quantity u plus v divided by the quantity 3u plus v times 3 times 4 times u. The 4's cancel out, and one of the u's in the numerator and the u in the denominator cancel out. You are left with 2uv times the quantity u plus v divided by 3 times the quantity 3u plus v. This expression has to have the same domain as the original expression. You took a u out of the denominator. If this u is equal to 0, then the entire denominator would be equal to 0 and the expression would be undefined. So u cannot be equal to 0. So the simplified expression is 2uv times the quantity u plus v divided by 3 times the quantity 3u plus v, where u is not equal to 0. Multiply and simplify. 12 minus r divided by 3 times 3 divided by r minus 12. Multiply the numerators and denominators. 3 times the quantity 12 minus r divided by 3 times the quantity r minus 12. Factor a negative 1 out of the quantity r minus 12. Negative 3 times the quantity 12 minus r divided by 3 times the quantity 12 minus r. The 3's cancel out, and the 12 minus r's cancel out. You are left with negative 1. This expression has to have the same domain as the original expression. You took a 12 minus r out of the denominator. If 12 minus r was equal to 0, then the denominator would be equal to 0 and the entire expression would be undefined. So 12 minus r cannot be equal to 0. Solve this for r. Subtract 12 from each side. Negative r cannot be equal to negative 12. Multiply each side by negative 1. R cannot be equal to 12. So the simplified expression is negative 1, where r does not equal 12. Multiply and simplify. The quantity 2x minus 3 times the quantity x plus 8 divided by x cubed times x divided by 3 minus 2x. Multiply the numerators and denominators. The quantity 2x minus 3 times the quantity x plus 8 times x divided by x cubed times the quantity 3 minus 2x. Write x cubed as x squared times x and factor a negative 1 out of the quantity 3 minus 2x. Negative 2x minus 3 times the quantity x plus 8 times x divided by x squared times the quantity 2x minus 3. An x in the numerator and denominator cancel out. And the 2x minus 3 in the numerator and denominator cancel out. You are left with negative x minus 8 divided by x squared. This expression has to have the same domain as the original expression. You took an x out of the denominator and a 2x minus 3 out of the denominator. If either of these terms are equal to 0, then the entire denominator is equal to 0, and the expression is undefined. So x cannot be equal to 0, and 2x minus 3 cannot be equal to 0. Solve the second equation for x. Add 3 to each side. 2x cannot be equal to 3. Divide each side by 2. X cannot be equal to 3 halves. So x cannot be equal to 0, and x cannot be equal to 3 halves. If x was equal to 0, the final expression would be undefined, regardless of what the original expression was. So there is no need to write that x cannot be equal to 0. So the simplified expression is negative x minus 8 divided by x squared, where x is not equal to 3 halves. Multiply and simplify. 4r minus 12 divided by r minus 2 times r squared minus 4 divided by r minus 3. Multiply the numerators and denominators. The quantity 4r minus 12 times the quantity r squared minus 4 divided by the quantity r minus 2 times the quantity r minus 3. Factor r squared minus 4 and factor of 4 out of 4r minus 12. 4 times the quantity r minus 3 times the quantity r plus 2 times the quantity r minus 2 divided by the quantity r minus 2 times the quantity r minus 3. The r minus 2's cancel out, and the r minus 3's cancel out. This leaves you with 4 times the quantity r plus 2. This expression has to have the same domain as the original expression. You took an r minus 2 and an r minus 3 out of the denominator. If either of these two terms were equal to 0, then the denominator would be equal to 0 and the expression would be undefined. When either of these two factors are equal to 0, then the denominator is equal to 0 and the expression is undefined. So neither of these two factors can be equal to 0. So r minus 2 cannot be equal to 0 and r minus 3 cannot be equal to 0. Solve these equations for r. In the first one, add 2 to each side. R cannot be equal to 2. In the second one, add 3 to each side. R cannot be equal to 3. So the simplified expression is 4 times the quantity r plus 2, where r is not equal to 2 and r is not equal to 3. Multiply and simplify. 2t squared minus t minus 15 divided by t plus 2 times t squared minus t minus 6 divided by t squared minus 6t plus 9. Multiply the numerators and denominators. The quantity 2t squared minus t minus 15 times the quantity t squared minus t minus 6 divided by the quantity t plus 2 times the quantity t squared minus 6t plus 9. Factor 2t minus t minus 15, t squared minus t minus 6, and t squared minus 6t plus 9. 2t minus t minus 15 factors into the quantity 2t plus 5 times the quantity t minus 3. T squared minus t minus 6 factors into t minus 3 and t plus 2. And t squared minus 6t plus 9 factors into t minus 3 and t minus 3. The 4t minus 3's cancel out, and the t plus 2's cancel out. You're left with 2t plus 5. This expression has to have the same domain as the original expression. You took a t plus 2 and two t minus 3's out of the denominator. When either of these factors are equal to 0, the denominator is equal to 0, and the expression is undefined. So these factors cannot equal 0. So t plus 2 cannot equal 0, and t minus 3 cannot equal 0. Solve each equation for t. In the first one, subtract 2 from each side. T cannot be equal to negative 2. In the second one, add 3 to each side. T cannot equal 3. So the simplified expression is 2t plus 5, where t is not equal to negative 2 and t is not equal to 3. Multiply and simplify. The quantity 4y squared minus x squared times xy divided by the quantity x minus 2y squared. Multiply the numerators and denominators. xy times the quantity 4y squared minus x squared divided by the quantity x minus 2y squared. Factor 4y squared minus x squared into 2y minus x and 2y plus x, and rewrite x minus 2y squared as x minus 2y times x minus 2y. X times y times the quantity 2y minus x times the quantity 2y plus x divided by the quantity x minus 2y times the quantity x minus 2y. Factor a negative 1 out of the denominator. x times y times the quantity 2y minus x times the quantity 2y plus x divided by negative 1 times the quantity 2y minus x times the quantity x minus 2y. The 2y minus x in both the numerator and denominator cancel out. You are left with negative xy times the quantity 2y plus x divided by the quantity x minus 2y. This expression needs to have the same domain as the original expression. The only thing you pulled out of the denominator was a 2y minus x, and there is already an x minus 2y in the denominator of the final expression, so the domain will be no different than the domain of the original expression. Multiply and simplify. X squared plus 2xy minus 3y squared divided by the quantity x plus y squared times x squared minus y squared divided by x plus 3y. Multiply the numerators and denominators. The quantity x squared plus 2y minus 3y squared times the quantity x squared minus y squared divided by the quantity x plus y squared times the quantity x plus 3y. Factor the x squared plus 2xy minus 3y squared into x plus 3y and x minus y. Factor x squared minus y squared into x plus y and x minus y, and rewrite x plus y squared as x plus y times x plus y. The quantity x plus 3y times the quantity x minus y times the quantity x plus y times the quantity x minus y, divided by the quantity x plus y times the quantity x plus y times the quantity x plus 3y. The x plus 3y's and x plus y's cancel out. You are left with the quantity x minus y times the quantity x minus y divided by the quantity x plus y. This can be further simplified to x minus y squared divided by x plus y. This expression has to have the same domain as the original expression. You took an x plus y and an x plus 3y out of the denominator of this expression. When either of these factors are equal to 0, the denominator is equal to 0 and the expression is undefined. So neither of these factors can be equal to 0. There is already an x plus y in the denominator of the simplified expression, so there is no need to specify that x plus y cannot be equal to 0. X plus 3y cannot be equal to 0. Subtract 3y from each side. X cannot be equal to negative 3y. So the simplified expression is the quantity x minus y squared divided by x plus y, where x is not equal to negative 3y. Multiply and simplify. X plus 5 divided by x minus 5 times 2x squared minus 9x minus 5 divided by 3x squared plus x minus 2 times x squared minus 1 divided by x squared plus 7x plus 10. Multiply the numerators and denominators. The quantity x plus 5 times the quantity 2x squared minus 9x minus 5 times the quantity x squared minus 1 divided by the quantity x minus 5 times the quantity 3x squared plus x minus 2 times the quantity x squared plus 7x plus 10. Factor 2x squared minus 9x minus 5 into 2x plus 1 and x minus 5. Factor x squared minus 1 into x plus 1 and x minus 1. Factor 3x squared plus x minus 2 into 3x minus 2 times x plus 1. And factor x squared plus 7x plus 10 into x plus 5 and x plus 2. The quantity x plus 5 times the quantity x minus 5 times the quantity 2x plus 1 times the quantity x plus 1 times the quantity x minus 1 divided by the quantity x minus 5 times the quantity 3x minus 2 times the quantity x plus 1 times the quantity x plus 5 times the quantity x plus 2. The x plus 5's, x minus 5's, and x plus 1's cancel out. You are left with the quantity 2x plus 1 times the quantity x minus 1 divided by the quantity 3x minus 2 times the quantity x plus 2. This expression has to have the same domain as the original expression. You took an x minus 5, an x plus 1, and an x plus 5 out of the denominator. If either of these factors were equal to 0, then the denominator would be equal to 0 and the entire expression would be undefined. So none of these factors can be equal to 0. X minus 5 cannot be equal to 0. Add 5 to each side. X cannot be equal to 5. X plus 1 cannot be equal to 0. Subtract 1 from each side. X cannot be equal to negative 1. And x plus 5 cannot be equal to 0. Subtract 5 from each side. X cannot be equal to negative 5. So the simplified expression is the quantity 2x plus 1 times the quantity x minus 1 divided by the quantity 3x minus 2 times the quantity x plus 2, where x is not equal to 5, negative 1, or negative 5. Multiply and simplify. 9 minus x squared divided by 2x plus 3 times 4x squared plus 8x minus 5 divided by 4x squared minus 8x plus 3 times 6x to the 4th power minus 2x cubed divided by 8x squared plus 4x. Multiply the numerators and denominators. Factor these polynomials. 9 minus x squared factors into 3 minus x and 3 plus x. 4x squared plus 8x minus 5 factors into 2x plus 5 and 2x minus 1. 6x to the 4th power minus 2x cubed factors into 2x cubed and 3x minus 1. 4x squared minus 8x plus 3 factors into 2x minus 3 and 2x minus 1. And 8x squared plus 4x factors into 4x and 2x plus 1. Write 2x cubed as 2 times x squared, and 4x as 2 times 2 times x. 2x and 2x minus 1 from both the numerator and denominator cancel out. This expression has to have the same domain as the original expression. There was originally an x and a 2x minus 1 in the denominator. If either of these factors are equal to 0, then the denominator is equal to 0 and the entire expression is undefined. So x cannot be equal to 0 and 2x minus 1 cannot be equal to 0. In the second equation, add 1 to each side. 2x cannot be equal to 1. Divide each side by 2. X cannot be equal to 1/2. So the simplified solution is x squared times the quantity 3 minus x times the quantity 3 plus x times the quantity 2x plus 5 times the quantity 3x minus 1 divided by 2 times the quantity 2x plus 3 times the quantity 2x minus 3 times the quantity 2x plus 1, where x is not equal to 0 and x is not equal to 1/2. Divide and simplify. X divided by x plus 2 divided by 3 divided by x plus 1. When dividing fractions, invert the divisor and multiply. This is the same thing as x divided by x plus 2 times x plus 1 divided by 3. Multiply the numerators and denominators. The simplified expression is x times the quantity x plus 1 divided by 3 times the quantity x plus 2. In the original expression, there is an x plus 1 in the denominator of a fraction. This means x plus 1 cannot be equal to 0. Subtract 1 from each side. X cannot be equal to negative 1. The simplified expression is x times the quantity x plus 1 divided by 3 times the quantity x plus 2, where x is not equal to negative 1. Divide and simplify. X squared divided by 3x divided by 4. When dividing fractions, invert the divisor and multiply. X squared times 4 divided by 3x. Multiply the numerators and rewrite x squared as x times x. 4 times x divided by 3x. And x in the numerator and denominator cancel out. You are left with 4x divided by 3. This expression has to have the same domain as the original expression. You took an x out of the denominator. If that x was equal to 0, the denominator would be equal to 0, and the expression would be undefined. So x cannot be equal to 0. The final expression is 4x divided by 3, where x is not equal to 0. Divide and simplify. 2x divided by 5 divided by x squared divided by 15. When dividing fractions, invert the divisor and multiply. 2x divided by 5 times 15 divided by x squared. Multiply the numerators and denominators. 30x divided by 5x squared. Rewrite 30 as 6 times 5 and rewrite x squared as x times x. 6 times 5 times x divided by 5 times x times x. A 5 and an x in both the numerator and denominator cancel out. You are left with 6 divided by x. This expression has to have the same domain as the original expression. You took an x out of the denominator, so x cannot be equal to 0. There's still an x in the denominator in a simplified expression, so there's no need to write that x cannot be equal to 0. Divide and simplify. 4x divided by 3x minus 3 divided by x squared plus 2x divided by x squared plus x minus 2. When dividing fractions, inverse the divisor and multiply. Now multiply the numerators and denominators. 4x times the quantity x squared plus x minus 2 divided by the quantity 3x minus 3 times the quantity x squared plus 2x. Factor the x squared plus x into x plus 2 and x minus 1. Factor a 3 out of the 3x minus 3, and factor an x out of the x squared plus 2x. 4x times the quantity x minus 1 times the quantity x plus 2 divided by 3x times the quantity x minus 1 times the quantity x plus 2. The x's, x minus 1's, and x plus 2's cancel out. You are left with 4/3. This expression has to have the same domain as the original expression. In the original expression, there was an x minus 1, and an x plus 2 in the denominator. So x cannot be equal to 0, x minus 1 cannot be equal to 0, and x plus 2 cannot be equal to 0. For x minus 1 cannot be equal to 0, add 1 to each side. X cannot be equal to 1. For x plus 2 cannot be equal to 0, subtract 2 from each side. X cannot be equal to negative 2. The simplified expression is 4/3, where x is not equal to 0, 1, or negative 2. Divide and simplify. 7xy squared divided by 10x squared y divided by 21x cubed divided by 45xy. When dividing fractions, invert the divisor and multiply. 10xy squared divided by 10x squared y times 45xy divided by 21x cubed. Multiply the numerators and denominators. 7 times 45 times x times y squared divided by 10 times 21 times x squared times x cubed times y. Factor 5, 3, 7, x squared, and y out of both the numerator and denominator. 7 times 3 times 5 times x squared times y times 3y divided by 7 times 3 times 5 times x squared times y times 2x cubed. The 7, 3, 5, x squared, and y from both the numerator and denominator cancel out. 3y divided by 2x cubed. This expression has to have the same domain as the original expression. In the original expression, there is both an x and a y in the denominator, so neither x nor y can be equal to 0. The simplified expression is 3y divided by 2x cubed, where x is not equal to 0 and y is not equal to 0. Divide and simplify. 3 times the quantity a plus b divided by 4 divided by the quantity a plus b squared divided by 2. When dividing fractions, inverse the divisor and multiply. 3 times the quantity a plus b divided by 4 times 2 divided by the quantity a plus b squared. Multiply the numerators and denominators. 2 times 3 times the quantity a plus b divided by 4 times the quantity a plus b squared. Separate the 4 into 2 times 2 and the quantity a plus b squared into the quantity a plus b times the quantity a plus b. 2 times 3 times the quantity a plus b divided by 2 times 2 times the quantity a plus b times the quantity a plus b. A 2 and an a plus b from both the numerator and denominator cancel out. You are left with 3 divided by 2 times the quantity a plus b. This expression has to have the same domain as the original expression. You took a plus b out of the denominator, so a plus b cannot be equal to 0. A plus b is still in the denominator of the simplified expression, so there is no need to write that a plus b cannot be equal to 0. So the answer is 3 divided by 2 times the quantity a plus b. Divide and simplify. 2x plus 2y divided by 3 divided by x squared minus y squared divided by x minus y. When dividing fractions, inverse the divisor and multiply. 2x plus 2y divided by 3 times x minus y divided by x squared minus y squared. Multiply the numerators and denominators. The quantity 2x plus 2y times the quantity x minus y divided by 3 times the quantity x squared minus y squared. Factor a 2 out of 2x plus 2y and factor x squared minus y squared into x plus y and x minus y. 2 times the quantity x plus y times the quantity x minus y divided by 3 times the quantity x plus y times the quantity x minus y. The x plus y's and the x minus y's cancel out. You are left with 2/3. This expression has to have the same domain as the original expression. The original expression had x plus y and x minus y in the denominator. If either of these factors are equal to 0, then the denominator is equal to 0 and the entire expression is undefined. So x plus y cannot be equal to 0 and x minus y cannot be equal to 0. Solve each of these for x. In the first one, subtract y from each side. X cannot be equal to negative y. In the second one, add y to each side. X cannot be equal to y. The simplified expression is 2/3, where x is not equal to negative y and x is not equal to y. Divide and simplify. The quantity x cubed y squared divided by the quantity x plus 2y squared divided by x squared y divided by the quantity x plus 2y cubed. When dividing by a fraction, invert the divisor and multiply. Multiply the numerators and denominators. The quantity x cubed y squared times the quantity x plus 2y cubed divided by the quantity x plus 2y squared times the quantity x squared y. Square each factor in x cubed y squared. X to the 6th y squared times the quantity x plus 2y cubed divided by x squared y times the quantity x plus 2y squared. Separate x to the 6th power into 6 x's, y squared into y times y, x plus 2y cubed into x times 2y times x times 2y times x times 2y, x squared into x times x, and x plus 2y squared into x plus 2y times x plus 2y. 2 x's in the numerator and denominator cancel out. A y in the numerator and denominator cancel out. And 2x plus 2y's in the numerator and denominator cancel out. You are left with x to the 4th power times y times the quantity x plus 2y. This expression has to have the same domain as the original expression. There was an x in the denominator, so x cannot be equal to 0. There was a y in the denominator, so y cannot be equal to 0. and there was an x plus 2y in the denominator, so x plus 2y cannot be equal to 0. Subtract 2y from each side. X cannot equal negative 2y. The simplified expression is x to the fourth power times y times the quantity x plus 2y, where x is not equal to 0, y is not equal to 0, and x is not equal to negative 2y. Divide and simplify. X squared plus 2x minus 15 divided by x squared plus 11x plus 30 divided by x squared minus 8x plus 15 divided by x squared plus 2x minus 24. When dividing fractions, inverse the divisor and multiply. X squared plus 2x minus 15 divided by x squared plus 11x plus 30 times x squared plus 2x minus 24 divided by x squared minus 8x plus 15. Multiply the numerators and denominators. The quantity x squared plus 2x minus 15 times the quantity x squared plus 2x minus 24 divided by the quantity x squared plus 11x plus 30 times the quantity x squared minus 8x plus 15. Factor each polynomial. X squared plus 2x minus 15 factors into x plus 5 and x minus 3. X squared plus 2x minus 24 factors into x plus 6 and x minus 4. X squared plus 11x plus 30 factors into x plus 5 and x plus 6. And x squared minus 8x plus 15 factors into x minus 3 and x minus 5. The x plus 5s, x minus 3s, and x plus 6s cancel out. You are left with x minus 4 divided by x minus 5. This expression has to have the same domain as the original expression. There used to be an x minus 5, an x minus 6, and an x minus 3 in the denominator, so none of these factors can be equal to 0. In the very beginning, x squared plus 2x minus 24 was in the denominator, which is equal to x plus 6 times x minus 4. So neither of these factors can be equal to 0 either. X plus 5 cannot be equal to 0, x plus 6 cannot be equal to 0, x minus 3 cannot be equal to 0, and x minus 4 cannot be equal to 0. So x cannot be equal to negative 5, negative 6, 3, or 4. The simplified expression is x minus 4 divided by x minus 5, where x is not equal to negative 5, negative 6, 3, or 4. The total annual amount, I, in millions of dollars, of personal income earned in Alabama, and its population, P, in millions, for the years 2004 through 2009 can be modeled by I equals 6,591 and 43/100ths T, plus 102,139, where 4 is less than or equal to T, which is less than or equal to 9, and P equals 184,000th T, plus 4 3/10, divided by 29,000th T, plus 1, where 4 is less than or equal to T, and T is less than or equal to 9, where T represents the year, with T equals 4 corresponding to 2004. Find a model Y for the annual per capita income for these years. The annual per capita income is equal to the total income divided by the total population. The per capita income is 6,591 and 43,000th T, plus 102,139, divided by 184,000th T, plus 4 3/10, divided by 29,000th T, plus 1. When dividing by a fraction, inverse the divisor and multiply. 6,591 and 43,000ths T, plus 102,139, times 29,000th T, plus 1, divided by 184,000th T, plus 4 3/10. Multiply the numerators and denominators. You are left with the quantity 6,591 and 43/100ths T, plus 102,139, times the quantity 29,000ths T, plus 1, divided by 184,000ths T, plus 4 3/10, where 4 is less than or equal to T, and t is less than or equal to 9.